Alright, one of the things we can do with polynomials is we can add or subtract them. So you can see the instruction here says simplify polynomials by combining like terms, or well, that's the objective. The instruction is just simplify the following. When we have addition both on the outside and on the inside of the parentheses, I can pretend this one is addition again by thinking of this term as -7, so that's why I'm comfortable saying there's addition on the inside of the parentheses and on the outside, which means I can just drop those parentheses. They're completely unnecessary. That's a quick reminder, this is called the associative property. It looks like this. A plus B plus C is equal to A plus B plus C, so you can just drop the parentheses, those are the same thing, or you could write it as A plus B plus C, where the B and the C are in the parentheses. So the associative property lets you add in or remove parentheses as long as everything in sight is addition. Now you might be saying, well, there's multiplication and there's exponents here. Not everything in sight is addition, but these are kind of higher up in the order of operations. So this right here, this term is clumped together more tightly, and ultimately I'm saying that there is addition is the last operation that takes place within these parentheses. So that's kind of how it behaves. It behaves as an addition problem, and that's why I'm able to say that there's addition both on the inside and on the outside of the parentheses, which allows me to just ignore them. So I'm going to rewrite it without the parentheses. Now that I've rewritten it without parentheses, now I can just combine like terms. Remember, to combine like terms, you have to have the same matching, you have to have matching variable parts. So this one right here, this x cubed, can combine with this other one over here, this other x cubed term. And to add them together, to combine them, I just add their coefficients, the -5 plus the 3, which gives me a -2. And I keep that variable part the same. So it's -5 plus 3 is -2. The x cubed is the variable part, so that's what stays there. Let's see, I can combine the x squared and the x squared term. So this one right here and this one right here can combine. As you can see, writing these little arrows can quickly become confusing. This is why it's not commonly done, but I'm doing it right now. And that wasn't a squared term, was it? I made a mistake. Or I was about to make a mistake, at least. This is just 4x. It's not 4x squared. So there's actually nothing for this 6x squared to combine with, so I'm just going to write it down. The 2x and the 4x can combine, and that gives me a 6x. This one and this one combine. 2 plus 4 is 6. And then we have, lastly, -7 plus 1 gives me -6. So combining like terms, or rather adding polynomials, is nothing more than just combining like terms, especially once we've dropped those parentheses. The same thing goes here. I'm going to rewrite it without the parentheses. Actually, yeah, I will rewrite it without the parentheses. Minus x plus 5 plus 3x squared plus 4x minus 2. These two combine to give me, looks like 12x squared. We have the opposite of x and the 4x, so this is a -1x. -1 plus 4 is 3, so we get 3x there. And these two combine to give me a 3 as well. You'll notice that by starting with the highest degree term on each of these, I'm starting out with the x cubed term, and then going the x squared, then the linear term, the one with just an x in it, and then the constant terms, the ones without any x's in them. Because I'm going in that order, I'm actually going in decreasing order by degree, or decreasing degree, whatever. Starting out with the highest degree and then working my way down, which means that this ends up in standard form. Same thing goes with this one. I started out with the squared term, then the linear term, then the constant term. So degree 2, degree 1, degree 0. And so this ends up in standard form without me having to do anything special. Alright, so this one right here, there is subtraction on the outside of the parentheses. This is something that will, you have to kind of watch out for. It'll sneak up on you. The subtraction on the outside of the parentheses, there is no associative property of subtraction. So instead what we end up having to do, let's just write up a quick example to see what it would look like. If we had a minus b plus c, we would have to distribute, but the way I'm distributing here is going to look a little weird, because essentially this is, I'm going to distribute the negative through the parentheses. I'm not distributing an a, I'm just distributing just a negative. Really, it's a -1 I'm distributing. I could rewrite this as multiplying by -1 and then doing all that. But, you know, usually when people do this, they just say, okay, I have a negative here, I'm going to distribute it to the b, giving me minus b. And then I have the negative, I'm going to distribute it to the c, also giving me minus c. So what this negative in front of the parentheses does is it distributes through these second set of these parentheses here, the ones that it's in front of, and it's going to change the sign of all of the terms on the inside of these parentheses. So over here, these parentheses, the first set of parentheses aren't really, nothing weird happens with them, so I'm just going to copy things down. It's the second set of parentheses where I need to distribute this negative through. I distribute the negative to the 3z, negative 3z rather, giving me positive 3z cubed. Because this was a negative 3z cubed, I'm changing its sign, it becomes a positive 3z cubed. Distribute my negative to the 9z squared, this becomes a minus 9z squared, and then distribute it over to this 1, the opposite of z first. I get a plus z, since that was minus z, and then finally the 1 gives me minus 1. So I distributed the negative through, now I can combine like terms. This one and this one give me a 9z cubed. Let's see, this one and this one, 2 plus negative 9, this is a positive 2. 2 plus negative 9, that's negative 7. And my variable part was z squared. Let's see, I don't want to jump to the constant. This is degree 2, and that would be degree 0. I'd be skipping over the degree 1. There actually is a degree 1 over here, so I'm going to write that next, just to make sure this ends up in standard form. So that's this one here. And then, what should I do? Maybe a little bump for the constants. So the negative 5 and the negative 1 combine to give me a negative 6. Now the whole point of simplifying these expressions, whenever we're simplifying an expression, if you wanted to kind of check your work, what you could do is you could pick some value, no matter what value you pick. If you were to plug it in for z into this expression up here, and then plug that same value of z into this expression down here, whatever this evaluates out to is going to be the same thing as whatever this evaluates out to. And on these questions, it's a lot of work actually just plugging this into the calculator, so that's maybe not the best method of checking your work, but you could do it that way. And really this is the point of why we're simplifying. Because instead of writing out this whole mess, if I can write out this mess, you know, it's still a little bit of a mess, but it's a lot less stuff to write. If I could write out this stuff instead of that, and yet it's always representing the exact same value, then this is kind of really preferable. And this is the whole crux of why we simplify things. It's because we want to write less, but still be talking about the exact same number. All right, last example for now. We have a negative in front of, or between the parentheses, and remember that only affects the parentheses that follow it. So I'm going to just copy out these first set of parentheses. We get 7x cubed, 3x minus 3x squared, and so on. And then I'm going to take and distribute my negative through the second set of parentheses. I get a negative 2x cubed because I distribute to the first term. Distribute to the second term, giving me a negative 12x squared. Distribute to the third term, giving me plus x, and distribute to the fourth term, giving me minus 1. Alright, combining like terms, I have these two, which are degree 3. 7 minus 2 is 5. This one and this one are both degree 2. They're specifically x squared. It's not just degree 2 terms, but they're like terms. Negative 3 and negative 12, those are both negative. They combine and become more negative, so we get negative 15x squared. The 2x and the x gives me 3x, because this is 2x here, this is 1x, 2 plus 1 is 3. And then lastly, 8 and negative 1 gives me 7.